Welcome to the Arcan demo. I'm Ilaria Pigazzini, co-founder and CEO. The purpose of this video is to show the main features of Arcan. On our website, you can find the user guide and all the detailed information about the tool. We start on the home page, where all software projects analyzed by Arcan are shown. Each project is represented by a card that summarizes the main information about the project. Specifically, at the top right, we find the technical debt index expressed in absolute terms, that is, an indication of how much technical debt is present within the last version analyzed. On the left-hand side, on the other hand, we find the technical debt index expressed in relative terms by exploiting a scale from A to F, where Class A contains projects with a low level of technical debt, thus the least in need of attention. The ranking was derived from a benchmark of more than 5,000 software projects. This index allows projects of different languages and sizes to be compared. Other information contained in this card. We find here the number of architectural smells and the number of lines of code, referring to the last analyzed version. Architectural smells are the software architectural level anomalies identified by Arcan and are the basis for calculating the architectural technical debt. Finally, the project card reports the trend of technical debt over time, depending on the code versions analyzed. In the case of this demo, 10 versions were sampled for each system over a 10-year time window. Clicking on the Inspect button or directly on the project name opens the section devoted entirely to the project under consideration, which consists of 3 pages: Overview, Assessment, and Comprehension. The page displayed at this time is the Overview, containing the dashboard with matrix summarizing the health of the project under consideration. All indicators should be read from left to the right, where on the right we have negative values. We have the technical debt spread, which tells us the percentage of the project affected by technical architectural debt. In other words, that contains architectural smells. In this case, 14% of the project is affected by the debt. Here we have the dispersion of technical debt, which tells us whether the debt is concentrated in one part of the project or is scattered. Having the debt scattered in different parts of the system is worse than having it concentrated, because in the case of refactoring, the whole code will have to be looked and modified, and therefore interventions cannot be isolated. Instead, design complexity tells us how well the different architectural components of the system are coupled together. It is calculated as the ratio of the number of architectural dependencies to the number of software components. On the other hand, rigidity tells us how likely a change to the code will cascade further changes. It is calculated through the instability metric defined by Robert Martin. Finally, the graph shows us the trend in technical debt over time, with more information than that shown in the card. The list of analyzed versions can be seen in the top left corner, and clicking on the specific version shows the results of its analysis. By clicking on Assessment, we open the page devoted to architectural smells. Here you can locate the problems that are causing the technical debt. Each row in this table represents an architectural smells identified by Arcan during the last analysis. Architectural smells are characterized by several attributes, including their type, the amount of technical debt they individually contribute to the total technical debt, and their criticality. Criticality is calculated using a machine learning model trained on a manually classified dataset by experienced programmers. In this case, in this table, its name is severity. The table can be sorted by attribute by clicking on the column headers. In the upper right corner are useful tools such as filtering for results and downloading the data. Clicking on the pink button will take you to the Detail tab for the individual smell, whose main focus is the graphical representation of the smell. In this case, we are looking at the hub-like dependency type smell that occurs when an architectural component has many dependencies, both incoming and outgoing, representing a bottleneck and unique point of failure for the system. In the upper left corner, we find some commands for navigating the graph. Reset layout, center the graph, and zoom. Once zoom is activated, we can use the mouse wheel or the default gestures to zoom. At the top right, we can select alternative layouts to the one recommended by Arcan and use the search bar to look for specific nodes in the graph. By clicking on the nodes or the arcs, which represent the architectural components of the system and their dependencies respectively, the source code can be viewed. Highlighted in red are the lines of code causing the architectural smells and from which one must start to apply the refactoring. Clicking on Comprehension takes us to the dependency graph configuration page. This section is intended to simplify the reverse engineering of software architectures. In the left column, you can select and deselect the architectural components that you want to display in the graph. In the column on the right, you can decide which types of architectural components or dependencies to display. For example, I will now choose to display the packages of this Java project and the dependencies between them. Clicking on Graph will take you to the page that renders the graph. As with the Smell Detail page, there are commands to manipulate the graph. The combination of different configurations with different layouts gives rise to what we have called architectural views, such as the one that you are looking at. I now show a further example. In this case, we chose to display Java classes and the inheritance relationship between them. When you're ready, you click again on Graph. Arcan automatically associates this configuration with the concentric layout, which allows, at a glance, to identify the set of classes from which most of the other classes in the system inherit. Architectural views recommended by Arcan team can be found in the online documentation. Thank you for your attention.